Hi, we're going to look at and try to work out some ideal stoichiometry. These involve mole-to-mole calculations. This is a very important type of problem, one which we will need to be able to master in order to understand stoichiometry. In the first question we're going to look at, we're going to be combining antimony with chlorine gas to produce antimony chloride. I've already balanced the chemical equation. In order to solve any stoichiometry problem, you must have a correctly balanced equation. So in this question we want to ask how many moles of chlorine gas are required to react with 5 moles of antimony. So what I like to do is, if I'm being asked how many moles of chlorine gas, right under the chlorine I'm going to write X moles, meaning that's what I'm looking for. And this is going to react with 5 moles of antimony, so underneath the antimony I'm going to write 5 moles. Now, the coefficients in a balanced chemical equation are sort of like a recipe where it says we need 2 parts antimony combining with 3 parts of chlorine, and that will give us 2 parts of antimony chloride. So to set this up, a mole-to-mole calculation, we're going to use the coefficients from the balanced chemical equation. I like to write these where I say, what am I looking for? That is, X moles of chlorine equal to, in this case, 5 moles of antimony. I'm going to use a conversion factor. The conversion factor will come, from the coefficients of the balanced chemical equation. Notice it says 2 moles of antimony will produce 3 moles of chlorine. Because I have moles of antimony here, moles of antimony go down here. So from the equation, we said 2 moles of antimony, 3 moles of chlorine. Again, I get this information, the 2 moles of antimony, 3 moles of chlorine, from the balanced chemical equation. 2 moles of antimony, 3 moles of chlorine. Now, my moles of antimony cancel each other like this. And I'm left with just the math. 5 times 3, 15 divided by 2, 7.5 moles of chlorine gas. And that's our answer. Now, this is the method that I think you should work using what we call dimensional analysis. Some teachers will show you a ratio method, and the ratio method works fine if we're working with just a mole-to-mole calculation. The problem is that if you use something like mole to gram or mole to liters, it will not work. So although I'll show you this method, it's not the method I want you to work these problems out with. And using ratios, we're just looking at 2 is to 5 as 3 is to x. So we set this up as a ratio. 2 is to 5 as 3 is to x. Now we set this equal, we cross multiply and divide. So 2 times x equal 5 times 3. So 2x equals 15, x equals 7.5. Now again, this method will work if you're only doing a mole-to-mole calculation. But that's not what we're going to be doing later. So my preference, my recommendation to you is not to use this method. So I'm going to get rid of it right now. Let's look at another question. How many moles of antimony chloride are produced from 5 moles of antimony and excess chlorine? Again, I'm going to write that information down. How many moles of antimony chloride, so that's my X moles, are produced from 5 moles of antimony and excess chlorine? When something is excess, it means you have more than enough, and in terms of working problems for us, it means we can ignore it. So really the question is asking us how many moles of antimony chloride are produced from 5 moles of antimony. Now some of you already know the answer because you said, well, there's a 2 in front of the antimony, a 2 in front of the antimony chloride, so that if you have 5 moles of antimony, you should produce 5 moles of antimony chloride. And that thinking is correct, but let's set it up just to show that is right. We'll write what we're looking for, X moles of antimony chloride, equal to 5 moles of antimony. We'll put in our conversion. Because we're at moles and trying to get to moles, we use the coefficient. Again, 2 moles of antimony will produce 2 moles of antimony chloride. Moles of antimony up here means that moles of antimony need to go in the denominator. So 2 moles of antimony will produce 2 moles of antimony chloride. Again, these numbers I'm getting right here are coming from the coefficients of the balanced chemical equation. 2 moles of antimony, 2 moles of antimony chloride. So that moles of antimony cancel. The 2's also will cancel, so I'm left with just 5 moles of antimony chloride. Seems pretty easy, doesn't it? Let's try another one. How many moles of antimony chloride are produced from 7.5 moles of chlorine and excess antimony? Again, let's write the information into the problem. We want to know how many moles of antimony chloride are produced from 7.5 moles of chlorine and excess antimony. So you can see I've added the information up here. So the question is really how many moles of antimony from 7.5 moles of chlorine. Set it up, what are you looking for? X moles of antimony chloride equal to what's given, 7.5 moles of chlorine. In order to go from moles of one substance, such as moles of chlorine, to moles of another substance, moles of antimony chloride, what are we going to use? That's right, the coefficients from the balanced chemical equation. 3 moles of chlorine will produce 2 moles of antimony chloride. So which one goes on the bottom here? Well, if you said because moles of chlorine goes here, then 3 moles of chlorine goes down here, you're correct, because you understand that the unit moles of chlorine and moles of chlorine must cancel. And again, the 3 moles of chlorine comes from the coefficient of the balanced chemical equation. 3 moles of chlorine will again produce 2 moles of antimony chloride. Moles of chlorine will cancel, and we just do 7.5 times 2, that's 15 divided by 3, and we get 5 moles of antimony chloride.